Hello class. So today I'm going to talk about section 8.2 linear function. Okay, what is a linear function? So let's have a definition of it. A linear function is a function of f defined by fx equal to mx plus b. Okay, mx plus b, where m and b are constant. And this is a linear function. Okay, so note that. So note that note that linear functions uh, is a, is a function of a line. Okay, so you will have a function of a line, um, um, and that's also going to call linear function. Okay, so let's do some example. Example one. Um, Identify linear functions from formula. Okay, so I have a f of x equal to 4 minus 3x. Okay. So in this case, is this a linear function? I would like to convert it. I would like to convert this to be look like in the form as mx plus b. So I would like to write as write the term with the variable x first. Okay, so I can rewrite it as f of x equal to negative 3x plus 4. And you can see now, I just change the position of the the x term stay first, and then that's the constant term is after that. So in here I can have slope m. M is slope. Okay, just tell you that slope m gonna be equal to negative 3. Okay, and b, which is y-intercept, but I will talk about that later. B in here is number 4. Okay, let me guys number 4. Okay, so then this is so then f of x equal to negative 3x plus 4 is a linear function. Okay, let's have another problem. Let me write better. So I have b f of x equal to 8. So it is a linear function. People want to say, there's no x at all. So it's not look like this form. So I cannot say this is a linear function. But actually it is. Now let me show you how to convert it, become the general form of the linear function. So can I rewrite it as f of x equal to something multiplied by x plus number 8. Okay, so you can right away know that, oh, the thing multiplied with x is going to be 0 because 0 times x is going to be 0, right? So then you have only 8 later on. So I can rewrite it as f of x will be equal to 0x plus 8. So then from here, you can say that f of x will be equal to 0x plus 8 is a linear function with slope m equal to 0 and b equal to 8. Okay. All right. Now, let me have another problem as f of x equal to 2x squared plus 8. Okay. So is this a linear functions? All right. So you see that in here, the thing that you need to consider, which is the x squared, the power is square here, right? So since it's have x squared, since f x contain x squared, then there is not a linear function. Okay, this become a parabola already, right? And also remember that. So note that if functions have has variable x with power greater than 1, then is not a linear function. So please keep in mind that with power greater than 1, then it's not a linear function. Okay. Okay. So let's move to another example. We'll do example 2. Identify linear function from tables of value. Okay, so now you're not looking at the formula of the function. You're looking at a table. So let's say I have table. You know what? Let me insert a table better. Okay. 2, 3. 1, 2, 3, 4. 4/2. Okay. Let me have this as a column A. I have X and then LX here. And then I have 0, 1, 2, maybe one more. 3. Okay, so this one is 10, and then 15, and 20, and 25. Okay. Okay. All right. Okay, so you want to know, is this a linear function? You need to check what's the difference in x. Okay, so from 0 to 1, you're adding 1 unit, right? From 1 to 2, you're adding 1 unit, and then from 2 to 3, it's adding 1 unit. So, so that means what? X is increasing. X is increasing 1 unit. Increasing 1 unit. Okay. Then what happened with the LX? From 10 to 15, so it's adding 5, right? And then 12, 15 to 20, it's adding 5. Oh, it's constantly adding 5. So, so I'm gonna say, and y is increasing 5 unit. Okay. So then I will say for each unit increase of x, f increase 5 unit. That means slope m equal to 5. Okay. And y-intercept which is b will be equal to f of 0. In order to find y-intercept, you wanna find when the case that's x equal to 0, and what happened with Lx in this case. So you see that b should be equal to 10, which is L of 0. Okay. So f of x will be in the format mx plus b is going to be rewrite as 5x plus 10. Okay, so note for after this exercise, you should know that b gonna be equal to f of 0. in order to find b, you're gonna find f when x equal to 0, and also m, so slope m. How can you find it? You're gonna see the ratio when x is increasing 1 unit, and how many units that's y increasing. So I would like to have a formula for you as y2 minus y1 over x2 minus x1 for the slope. Or sometimes it's say like the number of units, that's y increasing, that y increase over the number of unit, x increase. Okay, or change. It's just that. Okay. All right. Let's have another column. So I have column B here. Yeah, copy out this one. Okay. I will change all this. This should be -2, 0, 2, and 4. And it is 4, 2, 0, and -2. Okay. So firstly, you need to check if it is changing constantly for x and y. So I know that it's adding 2 for each x, right? See that? But what happened with the y? It's gonna be wait a second. It's gonna be adding -2 or -2 for each time move to the next f of x. So each time x increasing 2 units, y is decreasing 2 units. Okay, so x is increasing. Let me separate this column. 2 units, and y is decreasing or 2 units. Okay, so how can you find a slope? So we take a slope m will be equal to the number of y increase. In here, actually, like the y, like the number changing units of y changing, right? Y changing, change. I should rewrite it here. Y change. Number of units x change. Okay. So number of unit x change for each time. Okay. So each time x time where is it? Okay, they want me to save it. Okay, let me save this one. Yeah, 8.2. X time x change to 2 in it, then y change to -2. So I put -2 divided by 2. Right, see that? And if you simplify it, you're going to have a -1. Okay. Let me use this. Okay. And what about B? B will be the case that x equals 0. You see that? X equals 0, if x equal to 2, right? So, so f of 0 will be 2, right? So you will have f of x will be equal to mx plus b, which now gonna be -1 x plus 2. And that should be linear. Okay. That has to be the form of linear, right? Okay, so let's move to, oops. Let's move to next column. All right. C. Okay. Oops. Okay. C. Oh, C. C. All right. Oh my God. What happened? Okay. Okay. So let me clean this up. Okay, so this is C. Column C has 0, 1, 2, 3. Oops. 3. And I have here's 1, 2, and 4, and 7. Okay, so we want to check if x changing constantly. So I have +1 for each time it's changing, right? What about y? +1. Oh, now it's +2 and +3. Now it's different, right? So this is not this is not a linear function. Because each unit x increase x increase unit. Let me write it. X increase x unit increase. Okay, sorry. Let me rewrite this. X unit increase in x does not result in a constant change in f of x. So this is not a linear function, and I will just move to the next one. D. Okay. All right. From D I have nearly 2, 0, 3, and 5. And then for this, so it's 7, 7, 7, 7. Okay. You can see that x changing as adding 2, no, adding nice, adding 3, and then adding 2. Right? So x could be not constantly changing, but what happened with y? Let's see. So I have nothing change, nothing change, nothing change. Okay, so you can see that for any chain, in x, f of x does not change. So f of x is a linear function, right? And in this case, with slope, because f of x does not change, then slope gonna be just equal to 0, right? Because the changing of y is 0, then I don't care about the bottom. So 0 divided by something, just gonna be equal to 0. And then we wanna say we wanna find b, which is as x equals 0. So we know that's b equal to f of 0 and equal to 7. So then f of x will be equal to 0x plus 7. I can rewrite as f of x equal to 7. So this is called like a constant function. Okay. Since f of x equal to just a constant, then we call this constant function. Okay. All right. Okay, so let's have a definition of constant function. So constant function can be represented by f of x equal to b, and for example, f of x equal to -7. Or f of x equal to 2, something like that, right? Okay. Let's have another example. So do example 3. So graphing linear function by hand. Okay, so we're gonna do something as sketch a graph of fx equal to x minus 1. And then you're gonna use the graph to evaluate f of -2. Okay. Now let's see how can I do this one. I would like to solution. Right. Draw or set up. Let's say set up or making a t-table of value. Okay, so let's have this x. Here is f of x. I have, let's start with -1 and see what happened. And then 0 and then 1. Right. So what happened if x equal to -1? You want to substitute back into if x equal to x minus 1. In here I have x now become -1 minus 1, and that equal to what? -2. So I can coordinate a point as -1, -2. What else? I have 0, plug in, I have 0, -1, and I have -1, and then I have this is 0, comma, -1, and the other pair. And then 1 minus 1 going to be equal to 0. Then I have here as 1, comma, 0. Keep in mind that at the case that x equals 0, then you later on going to have this is y-intercept. Or b going to be equal to -1 in here. Okay, so good. Now let me draw the graph and then see what happened, right? Okay, so I will have let me see. So here we go, and then here we go. So I have say -1 here, 1 here, 0 here, and I have 1, -2, -1 here, and -2 for the y-axis. It's here, and then okay, I have y-intercept at 0, -1. So 0 and -1 going to be y-intercept. So 1 point should be here. We use color. 1 point here. What else? I have -1 and -2. So -1 put down here and then down here. So I have another point. It should be here. And then 1, 0. Okay, so this is x-intercept 1 0. Okay, so now you can just draw the line, go through this 3 point. I will use shape here. All right. Okay, so not really. Okay. Let me move this. Okay. And I make it bigger a little bit. How can I make it bigger? I think over here. Okay. Okay, now it's perfect. So this is the line that we need to draw, and if you want to have the formula, the function of it, you can have slope will be let me see. Slope will be and the number changing of x. Let's choose 2 point, maybe here to here. You're adding 1, right? And from here to here, you're also adding 1. Oh, sorry, adding 1. So it should be 1 over 1, and it should be equal to 1. And b, we know that it should be equal to -1. So then y equal to x minus 1. It's going to be the function of this line. By the way, we need to use a graph to evaluate f of -2, right? Oh, actually, you know what? Why I have to have this step according to here. I just want to verify from the given, right? It's exactly at the function that they give us. Okay. Now use a graph to evaluate of f -2. So you see where's an x equal -2 is here, right? You want to check what is the value of y now. So you in the graph, during the graph, you're going to see, oh, this should be -3. So I will say, let me move out here. I will say to evaluate f of -2, firstly, find x equal to -2 on the x-axis. Then move downward to the graph of f. So by moving across to the y-axis, we see the corresponding y value is -3. So f of -2 equal to -3. So according to the graph, but if you want to check, right? Say you want to check with algebra. So you can just substitute, f of x equal to x minus 1. So you're gonna just, if you're looking for f of -2, you're gonna just substitute into it. Then you're gonna have -2 minus 1, and that gives you -3. That is the reason why you have -3. Okay. Okay. So let's we move to let's see. Uh-oh. Okay. Let me move to modeling data with a linear function. Okay, so the formula fx equal to mx plus b may be interpret as follows. So you have f of x equal to mx plus b. So this is new amount. Maybe I have to rewrite it. New amount equal to mx, which is change, plus with b, which is fixed amount. So in here, we will talk more about the change. Or if we have change equal to mx, no, let me rewrite this. Change will be equal to rate of change multiplied by time. Okay. Like how much time you change. Okay. So which I can rewrite as mx will be m times x. So m in here is rate of change. Okay. So slope m can be also called rate of change. And then the and it can be mean that the output of linear function change by a constant amount for each increase in the input. So I have put down here, like summarize things for you now. Also, for an examples, you see that's like if I have fx equal to negative 3x plus 8, what is slope in here? M equals to negative 3. And the rate of change in here is you can call it, because the negative 3, right? Negative means decrease. So rate of change in here actually is decrease 3 units for h, increase in x. Okay. Similarly, if x equal to 0 to 5, which is a constant function. So in this case, m equal to 0, and the rate of change is going to be equal to 0. Okay. One more thing. Let's see. Oh, one more thing I want to talk is about midpoint. Okay, so one second. Okay, so let's talk about midpoint. If you have learned about midpoint in the last segment, say yes, -3 is 5, something like that. So so we have midpoint of this, what is going to be? Okay, so -2, -1, 0. Oh, I make so much bitch. Let's see here. Okay, so here. Here, 2, 1, 0, 1. 2, 3, 4. Right? So you can see that the midpoint in between 3 and 5 gonna be here, right? It is 1. How can you find it? You're gonna just take -3 you plus with 5, and then divide by 2. That's gonna give you 1 at the midpoint for a segment. Okay, but we are talking about the midpoint in the xy plane. Okay, so now let's talk about midpoint in midpoint formula in the xy plane. Okay. So I have midpoint formula in the xy plane gonna be m equal to, so remember midpoint is a point, right? And since it is a point, it should be a coordinate as xm comma ym. Okay, x, y, and x and y, right? Like all the pairs, you remember that. And you need to find what is xm and what's ym. It actually in the format, say x1 plus y1, sorry, y1 over 2. No, x1 and plus x2. Okay, sorry. And then comma y1 plus y2 over 2. All right. That should be the midpoint formula for the xy plane. Let me use this for you guys to easily see it later. Okay, so that is a way to That is formula for you to use and find the midpoint formula. You know, let me draw a column such as here is XY plane, right? You know what? Go this way. 1, 0 here, and I have you know, something like this. Here's 1 point here, another point. So here's x1, y1, and here's x2, y2, and the midpoint should be here. And I want to find is xm, ym. This is m. This is point m. Okay. So let's do an example. Right. Example 9. Finding the midpoint of the line segment connecting the points -3, -2, and 4, 1. So what I do for this problem is I always gonna write on the top of these two with some label as x1, y1, x2, y2. Because later on, when I apply for the midpoint m equal to x1 plus x2 over 2, comma, y1 plus y2 over 2. Remember that it should have the m should be in the format order pair, right? So so I should have something like parentheses, right, and comma in the middle. So now I have x1, I'm gonna just substitute. X1 gonna be -3 plus x2 is 4 divided by 2, comma, y1 is -2, and plus with y2 gonna be 1 divided by 2. Then I have answer as 1/2, comma, -1/2, and that should be the answer for m. Midpoint. Okay, so that is a way to find the midpoint, and I actually have summarized things over here for you to follow 4 concepts over here. Okay, so first thing is talking about linear function, constant function, and rate of change for linear function, and midpoint over here. See that? Okay, so then I'm gonna stop section 8.2 now, and see you next time on section 8.3. Bye.